Okay. Okay, I just had to stop recording. I restarted it. Let me get back to the notes though. Now that was less than 30. For the percentage of years less than 40, right? Well, in that case, it's the same idea, except now instead of 30, we're going to use 40. We have to get the z-score for 40, okay? That's what we have to do. Yeah, they can see it. Okay, so again, we do the calculate, right? We take the 40, the data value, we minus, that is, we subtract the mean, and we divide by the standard deviation, okay? That's what we're doing. We divide by the standard deviation, and when you do that, you get the z-score of 1.1607. That's our z-score. Now, if we go back to the table, okay, again, I gotta go to the table, so let me stop sharing this again. Again, the notes are in your, what do you call it, your email. I emailed them to you, so you should have the notes anyway. Okay. But now we have 1.1617, I think it was. Let me just double check. I don't want to make a mistake. 1.1607, okay? But if we don't have 1.1607, that's not in the table. But rounding, we can round it to 1.2. And what we get is this, it looks like, which is 0.8849. So for 40, the data values to the left of 40, less than 40 inches, is the same as the percentage of data values less than the z-score, 1.2, which is about 0.8849. So as a percentage, we get 88.49%. Okay, I had to stop sharing that. Let's see. Here it is. So again, we're back here. We have 88.49%, right? Again, from the data, from the table, we have 1.2, okay? And from there, because we had the round, we had 1.1607. Again, we're trying to get the percentage of data values less than 40 inches, okay? Less than 40 inches. That's what we're looking at here. Okay, but again, this was not in the table, so we rounded to 1.2, and that's what we got. We got this from the table, 0.8849. But again, we wanted to be a percentage, so we converted it. So about 88.49% of the years, okay, that have less than 40 inches of annual rain is about 88.49%. So that's what we have here, okay? Good. So the percentage of values that have an annual rainfall, okay, less than 40 inches is about 88.49%. Okay, let me just do this now. For 3, this is really what I was trying to say before. You have to subtract data values. Here, we have the percentage of data values, the percentage of years that have an annual rainfall between 30 and 40 inches, between 30 and 40 inches. So now we're between, right? Well, we can look between the z-scores just like we did just like I showed you shortly before, right? On a previous slide. And what we do is we subtract the z-score for 40. No, excuse me, we subtract the percentage for 40, or the how do I say it? The table entry for 40, thank you, minus the one for 30. And that's what we're doing here. We're just subtracting. So remember, this is the area to the left of 40. This is the area to the left of 30. You want the area between. What I was trying to show you is we subtract. Okay, that's what I was trying to show you here. So it's almost like Z1 here would be 30. Excuse me, Z1 would be the z-score for 30. Z2 would be the z-score for 40. So Z1 would be for negative 6.25. Z2 would be 1.16, I think it was. But to get the area, we have to subtract, and that's what we're doing. And we get that the area between is about 0.6106, so about 61%, 61.06% of the years have annual rainfall between the two. That's all I'm trying to get you to see. Graphically, this is what we're doing here. You know, this was for the first z-score, negative 0.625. This is the area to the left. Here, we have the area to the left of the other z-score, which is 1.1617. And to get the area between, we subtract, and that's what I did here. That's how I got this. I subtracted. That's what's happening here. Let me show you also, let me just wait. Okay. Let me show you also, okay, how to get this through Desmos. So I'm going to have to go back to Desmos, okay? Let me just get this over here. Good. All right, so let me go back to Desmos. Okay, here it comes. So again, we have negative 0.625. We have the z-scores, right? For the other z-score, it was 1.1617, I think. Let me double check. I don't want to give you wrong answers. 1.1607. Okay. That's all right. It's easy to fix. Graphically, we have this. So again, I'm using Desmos now. We're getting the area between, right? And this gives us the actual answer. It's pretty close to what we got in the slide. I mean, it's not going to be exactly the same, don't forget, because we rounded. Okay. But again, on the slide, we got 61.06%. And on Desmos, it tells us it's, as a percentage, it's 61.11%. So that's all. Okay, where am I? Yeah, here we go, here we go. Okay, so we have that. Let me now go back to the slides again. Okay. All right. Yeah, I hope that makes sense to everyone. This one I was going to let everyone try, but I think it's better now for us to do it together. Okay, because, you know, the last lecture we had was Thursday before Thanksgiving, so I think it's better if we do this together. So this is another word problem that I got from the book, and they tell you that, hope I'm saying this word right, the systolic blood pressure of males. Okay, so they're measuring blood pressure, I guess, a certain type of blood pressure, systolic. I don't know if I'm saying that word right, but they have a bunch of data values and they plot it, and it turns out the data has an approximately normal distribution. The mean is 125 and standard deviation 4. So the data values here are different blood pressure values, different blood pressures values in millimeters of males. So for a bunch of males, I don't know how many they're measuring, but the mean of those blood pressure values is about 125, and its standard deviation is 14. And those blood pressure values, kind of like IQ scores, and, you know, for people, that is, and what was the other one? I think for weight, body weight of people, I think, it's also about normally distributed. So the first question is, okay, what percentage of males, that is, what percentage of data values here, had a blood pressure less than 140 millimeters? Again, we have a normal distribution, right? What we're going to do is convert to the z-score and then get the area to the left of it. Now, we could use the table, and we could also use or Desmos, that is. So just like the other example, I'm going to show both. So let me do that. Let me see. So for 140, okay? Wait, actually, let me do this. There we go, there we go. So for 140 now, okay, over here, we have to get the z-scores, right? So how do we do that? We subtract the mean and divide the standard deviation. We divide by the standard deviation. We subtract the mean and divide. So the z-score for 140 millimeters for 140 is 1.0714. So that's the corresponding z-score, okay? And again, this is percentage of data values less than it. So we want the area to the left of this z-score. So we could go back to the table. Let me do that. So let me just pause the recording.